Welcome to the Deep Dive, the show where we take a stack of sources that really shouldn't belong together and try to find the profound truth that binds them.
And today, I think we've hit a new level.
Today we have achieved, I think, peak philosophical absurdity, and honestly, the connections we're about to unpack are they're deeply rewarding.
It is certainly a unique collection. I mean, we are bridging millennia here and radically different disciplines.
Totally.
We're connecting things most people would never, ever dream of putting in the same sentence.
Exactly. So our source material today forms this unlikely, you could almost say impossible, trinity. On one hand, you have the immense perennial influence of the King James Bible.
Right, what George Sampson called the greatest English book.
The very one, the foundation of spiritual and, linguistic truth for centuries. Then we have the ancient, enduring traditions of Freemasonry.
With its focus on moral geometry, the craft of stone, and that whole concept of structured secrecy.
And in the third corner, we have the cutting-edge, ultra-modern world of global tech.
Google Site Reliability Engineering, or SRE.
Yep. Dealing with distributed systems, microservices, latency, automated failure response, all of it.
So you've got theology, moral geometry, and code.
Stone, soul, and software. I mean, these fields are so wildly separated by time, by focus, by technology. And yet our mission for this deep dive is to extract the shared poetic and allegorical similarities that bind them all together. We are looking for those universal human patterns.
How we strive against decay.
Right. How we structure knowledge so it can endure. And maybe most importantly, how we respond when systems, whether they're spiritual or digital, inevitably fail us.
That is precisely the framing we need here.
Yeah.
I mean, our task is really to prove that when you strip away the technical jargon,
all the SLOs and APIs,
and the esoteric names like Borgmon, which is, Google's proprietary monitoring system, it's essentially the nerve center that keeps things running.
Okay.
When you strip that away, SRE reveals itself not just as a practical set of IT best practices, but as a deep, almost moral philosophy.
A philosophy of structure.
Of structure, fidelity, and behavior.
Yes, I love that idea. SRE as a moral philosophy. It's a philosophy built around this common human quest for an impossible ideal.
Absolutely. For the ancient builders, that quest was for permanence.
For eternity.
Right. They were aiming to create structures that would just defy the entropy of time. And for the theologian, it's about perfection or fidelity to a divine, unchanging word.
So what's the SRE equivalent?
For SRE, it's the 100% reliable system.
Which they know is impossible.
They know intellectually they can never ever reach it because failure is inevitable.
Right.
And yet they must perpetually strive for it, even while they're planning for its impossibility.
So if the ancient builders wanted monuments that were firm as the heavens and the theologians were after this pure, untouched word, what we're going to see is how the processes for guarding an ancient sacred text share a philosophical lineage with the modern distributed processes for protecting a petabyte-scale database from corruption.
That's the thread. It's the same human impulse, just with different tools.
Okay, let's start with that foundation then. The concept of the text, this pure, stable, and untainted source that everything else depends on.
Because if the foundation is corrupted,
everything built upon it is unstable.
In the Western theological and linguistic world, that untouched source, particularly for English speakers, is, it's undeniably the King James Bible. Its influence is described as tremendous, all-pervasive, and perennial.
And not just on religion, but on the English language itself.
Exactly. George Sampson's declaration that it's the greatest English book isn't just about its spiritual themes. It's about the sheer volume of vocabulary and literary styles it helped shape.
And it's not just big ideas, is it? It's the linguistic bedrock of our daily conversation.
Oh, absolutely.
It's fascinating how many of our everyday phrases are essentially direct biblical quotes, or maybe slightly adapted references that we use without even thinking about where they came from.
We're talking about foundational idioms that govern how we interact. I mean, when we ask, am I my brother's keeper?
From Genesis.
Right. Or, when we decide to eat, drink, and be merry.
Luke.
Exactly. Even less obvious ones, like complaining about a thorn in the flesh or saying something is like casting pearls before swine.
These are all deep-seated linguistic anchors. And this pervasive penetration into common speech, it's not some accident of translation.
No, it speaks to the stylistic choices the KJV translators made.
What do you mean?
Well, the sources suggest that for sacred truths to really resonate with people, the language should feel a little archaic.
Just removed enough from daily chatter to feel important.
Exactly, a bit lofty. And it needs to employ symbolizing imagery.
That stylistic decision is so crucial for our deep dive. I mean, by creating an officially sanctioned text that relies so heavily on symbolic distance and metaphor.
The KJB basically established the linguistic framework for allegorical thinking itself.
So if the text operates on a layer of symbolic mystery, it naturally lends itself to interpretation and application across wildly different domains.
Like, say, reliability engineering.
Exactly. Now let's look at the incredible, painstaking, centuries-long effort that was required to maintain this foundation, to guard the urtext from corruption.
Whether that corruption is a simple clerical error or a faulty software deploy.
Right.
The historical parallel here is just fascinating. It's the work of the Masoretes.
These were Jewish scholars, right?
Right. Working over several centuries, roughly between the 7th and 11th centuries, and they devoted their entire lives to ensuring the textual purity of the Old Testament. Their mission was explicitly to correct textual faults that had crept into the text.
So they were like ancient auditors.
And more. They wanted to put systemic measures in place to prevent any future corruption from happening.
This was quality control at an obsessive, almost spiritual level.
It was. They didn't just copy the text, they treated it like the most critical data set you can imagine. To prevent even a single missing letter, the Masoretes counted every single word and every single letter in every book.
Wow.
They established these incredibly complex numerical systems to track this integrity.
So like an early form of a checksum.
A very, very early form, yes. For example, they would mark the middle verse of each book. So if a new scribe was copying, say, the book of Deuteronomy, they had a built-in checkpoint.
And if the count was off?
If the copyists reached that middle verse, and their count didn't match the established Masoretic text, they knew an error had occurred, and the entire copy was suspect.
So they had to throw it out and start over.
Precisely. They rigorously collated all these different regional textual traditions and eventually codified landmark editions like the Aleppo and Leningrad codices. This required immense institutional discipline over generations.
And this rigorous, almost paranoid focus on integrity and establishing an authoritative source, this monumental feat of preventing corruption, is exactly the allegorical core we're connecting to modern reliability engineering.
It connects because SRE operates on the same principle of end-to-end data integrity.
So if the Masoretes use letter counts,
SRE uses checksums and cryptographic hashing to ensure that data leaving point A is mathematically identical when it arrives at point B, and that the data just sitting in storage hasn't suffered from what they call bit rot.
that dedication to letter-perfect accuracy in the face of transmission failure or decay is philosophically identical.
It is.
And we see a similar kind of rigor, though with maybe different motivations, in the creation of the New Testament basis for the KJB.
The Textus Receptus.
Assembled by Erasmus in 1516. And this involved navigating these complex conflicts between the existing Greek manuscripts and the official established Latin Vulgate.
And this is where the philosophical tension gets really interesting, because sometimes integrity clashed with, well, completeness or harmonization.
What's a good example of that?
Our sources detail the inclusion of the phrase, "It is hard for thee to kick against the pricks."
From Acts.
Right. But Erasmus admittedly lacked that phrase in the Greek manuscripts he actually had in front of him.
So why include it?
Because it was present in the Latin Vulgate and other established versions. He included it to make the text feel complete and authoritative to the established church tradition, even if its immediate Greek origin was a bit debated.
So this wasn't necessarily a failure of integrity?
Not in his view. It was a choice. Sacrificing pure manuscript fidelity for the sake of established harmony and completeness in the final product.
And that choice, that tension between pure integrity versus harmonization, is something engineers face constantly.
All the time. Does a modern engineer rush a patch that's 99% tested to restore service immediately?
Prioritizing completeness or speed over integrity.
Or do they wait for 100% rigorous validation, potentially leaving the service degraded for longer? The Masoretes and Erasmus show us that this battle over textual purity is deeply human and it's perennial.
So how does this quest for an untouchable foundation translate into the world of builders and, eventually site reliability engineers?
For ancient builders, the quest was explicitly for permanence. They sought to construct things that were firm as the heavens, aspiring to eternity.
They wanted to build things that would defeat decay.
Exactly. We hear of Akhenaten founding a city foursquare, specifically to endure forever. And to achieve that, Everything else was sacrificed.
Mm.
Expedience, speed, temporary comfort, all of it was secondary to this ultimate aspiration toward eternal stability.
That's such a profound, almost religious contrast to the modern digital world.
How so?
The ancients sought stability that transcended time, but SRE operates under the baseline kind of brutal assumption that systems are inherently imperfect.
They call them imperfect machines.
Right, and they're prone to failure at all times. They just accept decay as a constant truth.
Exactly. The SRE worldview accepts failure as a given, an inherent property of the system, unlike that ancient belief in a perfect eternal creation. And yet, they still strive for a kind of engineered permanence.
True layered redundancy. It's a recognition of managed decay.
It is. And this is where we need to elaborate on the mechanism of N+2 redundancy.
Okay.
This phrase sounds like jargon, but it is the SRE's version of building Foursquare.
So break it down for us. What does N+2 actually mean in practice?
Okay, so N is simply the baseline capacity you need to serve peak traffic to your users. That's the minimum.
The +2 is the sacrificial provision for inevitable failure.
That's it. The first N+1 capacity buffer is reserved for planned maintenance. You have to take components offline to update them, and you want to do that without impacting users.
And the second, +1.
That's the allowance for the completely unplanned failure, the chaotic event, a network outage, a regional power failure, a sudden, unexpected flaw in the code.
So SRE deliberately over-provisions to absorb two simultaneous failures, one planned, one chaotic, without the user noticing an unacceptable degradation in service.
It's the modern version of building Foursquare to endure forever. But instead of sacrificing everything for a hope of eternity, SRE sacrifices immediate resources.
Like compute power, money.
Right. They sacrifice those things to ensure against the inevitability of decay and failure.
They are protecting the integrity of the data and the service flow, just as the Masorettes protected the letter text.
The Masorettes counted letters. SRE counts milliseconds of availability. But both actions are designed to ensure the foundation remains pure and stable in the face of chaos.
Okay, so moving from the foundation, we get to the structure itself. In every domain we're looking at, achieving order seems to require imposing objective, abstract principles onto a chaotic reality.
Geometric, spiritual, mathematical.
Yeah. In the Masonic tradition, this imposition of order is explicitly moral. It defines character as much as it defines architecture.
Right. The author, Joseph Newton, he draws on Ruskin's classic Seven Lamps of Architecture.
Yeah.
And he explains that architectural laws are moral laws. They apply to your personal character just as much as they apply to a cathedral.
And Ruskin identifies 7 of these lamps: sacrifice, truth, power, beauty, life, memory, and obedience. All of them are required for true architectural integrity.
But let's focus on 2 of them, obedience and sacrifice, because they translate so perfectly into SRE culture.
Obedience is key. Ruskin's whole thesis suggests that true liberty isn't wild, chaotic freedom.
No, it's achieved through strict obedience to the fixed laws of life and truth. The stars, the earth, the sea, they don't have liberty. They follow cosmic rules.
And violating these moral laws, Ruskin argues, inevitably spoils the beauty and the stability of the architecture.
Which requires sacrifice. The willingness to sacrifice your personal preference, your time, or cost in favor of the integrity of the design.
And this moral requirement is represented visually and practically through the builder's tools.
Absolutely. You have the square, which is an emblem of truth, justice, and righteousness. It's often called a great step in geometry because it enforces right angles and consistency.
And then the plumb line,
which signifies walking uprightly by the plumb line of rectitude. These are objective, unchanging geometric standards that are applied to the very subjective, often messy, human activity of building.
It's the ultimate allegory, right? Using fixed, universal angles and measurements geometry to dictate honorable action and structural integrity.
And what's fascinating is how SRE translates this ancient geometric discipline into a quantitative digital framework.
SRE's system of service-level indicators, SLIs, and service-level objectives, SLOs, is their modern digital geometry.
But we have to be precise about the distinction here to really appreciate the analogy.
Okay, so help us define that precision. How does an SLI differ from an SLO?
The service-level indicator, the SLI, is the raw measurement. It's the observation.
So the measurable frequency of successful requests or the latency in milliseconds?
Or the error rate, exactly. This is simply the builder taking a measurement. It's the uninterpreted data point. It's the Masorettes counting letters.
But the service level objective, the SLO, that's the policy you impose on that measurement.
Yes. That is the plumb line itself, the geometric standard. The SLO states we must be 99.95% available over this month, or latency must be below 100 milliseconds for 99% of requests.
It is the explicitly defined quantitative goal that enforces the moral structure.
And that objective is designed to remove all ambiguity. The engineers know exactly what is expected and whether the system is walking uprightly.
Which brings us to the error budget.
The most profound allegorical connection here. If the Masonic plumb line dictates rectitude in action, the error budget dictates disciplined risk tolerance in development.
The error budget is the sacrifice made explicit.
Exactly. It's the discipline made quantitative. It is a clear, objective metric agreed upon upfront by both the SRE team,
Who are the arbiters of stability?
and the product development teams, who are the arbiters of speed and new features.
And its fundamental purpose is to remove all those subjective elements like politics, fear, or hope from feature deployment decisions.
It says, essentially, you have agreed to be 99.99% available. That means you are allowed 52 minutes of downtime per year. That is your air budget. Spend it wisely.
And it structurally enforces stability by preventing excessive high-risk change.
It does. If a development team introduces a risky new feature that chews up 10 minutes of that error budget,
They're all locked out.
they are immediately locked out of deploying new code until they dedicate their time to fixing existing reliability issues. They must obey the geometry.
I love that SRE's unofficial motto is, hope is not a strategy.
It's pure moral geometry applied to software deployment.
It demands rational rigor, and you see how rigorous this is when they actually monetize the pursuit of perfection. They turn a spiritual ideal into a spreadsheet.
Oh, they literally calculate the financial value of reliability.
What?
It enforces that ethic of sacrifice. Let's walk through a hypothetical.
Okay.
Let's say a major e-commerce service is currently at 99.99% availability. That's about 52 minutes of downtime per year.
Okay.
And leadership wants to move to 99.999% availability, what they call 5 nines, which is only about 5 minutes of downtime per year.
Sounds great in theory, but those last few nines get incredibly expensive.
Precisely. If the analysis shows that the cost of engineering time, advanced hardware, and new testing infrastructure required to achieve that extra 9 is, say, $500,000 a year.
But the extra revenue you get by reducing that downtime is only $200,000.
Then SRE dictates the decision.
The investment is mathematically unwarranted. The pursuit of perfection beyond the economically rational point is a waste of resources.
You stop at 99.99%. SRE transforms the abstract ideal of good service into a mathematically enforceable contract. The geometry is defined by the needs of the system and the business value, and you are morally or financially obligated to adhere to it.
This idea of imposing structure for moral or spiritual benefit is also tied to aesthetics, right? Specifically simplicity and minimal design, which reinforces stability.
Right. The ancient builders sought perfected geometric forms, like Ichnaton's four-square city. This focus on perfected minimal form echoes that famous quote by Antoine de Saint-Exupéry.
Perfection is finally attained not when there is no longer more to add, but when there is no longer anything to take away.
That aesthetic principle is central to SRE design. They champion minimal APIs, fewer methods, fewer arguments, fewer configuration options.
Why?
Because complexity is the enemy of reliability. A simpler API is easier to understand, it requires less documentation, less effort to support, and it's a hallmark of a well-understood problem.
It forces the designer to be disciplined enough to solve the root problem, not just add a bunch of quick-fix features.
And this leads directly to modularity. Loose coupling between system components ensures stability. It means if one binary fails, if one component, built square and plumb, is compromised, the whole interconnected system doesn't collapse.
So this disciplined approach to design, focusing on what is essential and removing everything else, ensures that the system is governable, measurable, and ultimately reliable.
Which is the goal.
Okay, so despite the pursuit of eternal foundations and perfect geometry, all our sources agree on one thing. Failure is inherent.
It's going to happen.
Systems crash, structures degrade, great losses occur. The defining characteristic of these three domains is not avoiding failure, but having a deliberate, structured journey, a quest back to the source of truth or stability.
The quest legend is a universal fundamental pattern in human history. I mean, whether it's woven around the Holy Grail, the recovery of a lost word, or the search for an unfinished design.
It always contains a memorial of a great loss.
A great loss, a belief that the lost thing still exists deeply buried or obscured, and this faith that it will ultimately be found and the vanished glory will be restored.
In Masonry, this quest for recovery is immortalized in the Hiramic legend.
Right, the master builder Hiram Abiff lost his life in consequence of his unshaken fidelity.
So the recovery involves this arduous, dramatic search by his associates, and they mark the spot with a sprig of acacia.
This is the ritualistic portrayal of loss and recovery. It represents the unconquerable faith of man against death, decay, and chaos. It's not just a story, it's a ceremonial process to reinforce the necessity of fidelity, even in the face of utter system failure.
And biblically, we have the great allegory of collective deliverance from systemic failure.
You're thinking of the crossing of the Red Sea.
Exactly. It was a chaotic event, a complete structural failure of the Israelites' previous situation, checked only by this divine intervention through the pillar of fire and cloud.
And it's not just the chaos of the loss that matters. It's the structured, faithful response. The event is commemorated as a happy deliverance achieved through fidelity.
Through Moses stretching his rod.
Right. The focus is on the deliberate, structured steps taken in the face of chaos that led to recovery and institutional learning.
Which brings us to the modern digital equivalent, the SRE failure rituals.
SRE fundamentally accepts that outages happen. In fact, the vast majority of outages are caused by pushing a change.
So their response to failure is highly formalized to facilitate rapid recovery and, crucially, institutional learning.
Much like the ritualization of the ancient quest. And the centerpiece of this ritual is the blameless postmortem.
But this isn't just a meeting, it's a structural document with a really rigid format.
And its primary goals are ensuring documentation, thoroughly understanding all the contributing root causes, and critically, putting effective preventive actions in place.
And the blameless culture is the philosophical prerequisite for this whole quest. Why blameless?
Because the assumption is that the people involved were intelligent and well-intentioned. Therefore, if a catastrophic error occurred, the focus shouldn't be on punishing the person.
But on fixing the environment.
Exactly. Improving system design, eliminating toil, making information readily available so that same mistake cannot be repeated by someone else.
This is a radical, almost moral approach to failure. It shifts the entire focus from individual fault to systemic weakness.
And it ensures the quest for improvement is institutional, not punitive. The post-mortem document, in its final state, demands quantifiable action items, not we'll try to do better, but Engineer X will automate this rollback process by next Tuesday.
We even have a fantastic analog from other high-stakes industries.
The lifeguard example.
If a lifeguard's feet go in the water, there will be paperwork.
That's the core concept. Even a near miss, or a very minor incident, requires a detailed write-up and a collective examination. The paperwork, the ritual forces, institutional learning, and operational changes. It's not about placing blame on the single individual who got their feet wet.
That structure is what makes the recovery effective, and it mirrors the SRE approach perfectly.
It does.
But to truly appreciate the allegorical quest in the SRE world, we need to look at the scale of recovery that's sometimes required.
The Google Music Data Integrity Case Study.
This wasn't just a brief outage. This was a fundamental corruption of the urtext.
It was an epic story of loss and recovery that rivals any ancient saga. A faulty data deletion pipeline, a corrupted digital maintenance ritual, if you will, started incorrectly removing audio data from users' libraries.
They caught it because of monitoring alerts, but the recovery was genuinely Herculean.
The loss was massive. 1.5 petabytes of user data was effectively deleted. And because this data was held on tapes in offsite storage, the deepest recesses of the digital temple, the recovery required retrieving data distributed among thousands of physical tapes.
And the complication was that the software they had to do this wasn't built for a recovery of this size.
Not at all. Their custom-built tape backup software was never designed to handle a single restore operation that immense. It was built for routine, individual recovery. But here they needed to restore thousands of individual user accounts, not one monolithic database.
And they realized they would have to split the recovery into, what was it?
Exactly, 5,475 individual restore jobs.
Now just imagine the toil involved there. The source notes that it would take a human operator typing one complex manual command per minute more than 3 days just to request that many restores.
And a human would inevitably make mistakes that would compound the disaster.
So the quest could not be completed by manual, heroic effort.
No. The solution wasn't simply restoring the data. It was developing a new programmatic solution just to interface with the tape backup system and request the restore. They had to engineer their way out of the manual problem before they could even begin the physical data recovery.
This just illustrates the arduous, complex quest for lost data, a modern saga of retrieving a deeply buried truth from a metaphorical grave.
And it required engineering prowess, adherence to systematic procedure, and an unwavering faith in the underlying recovery systems. The quest for purity required a whole new layer of automation.
And the ultimate realization gained from this quest is that failure is so beneficial, so rich in instructional material, that SRE must proactively embrace chaos.
Through rigorous testing,
This is disaster recovery testing, or DIRT.
the proactive and deliberate breaking of systems to understand their failure modes and identify weaknesses before real chaos strikes. You load test components until they break, noting exactly how they degrade.
Do they serve errors gracefully, or do they just crash entirely?
This creates institutional knowledge about the system's limits. And crucially, SRE values negative results.
Realizing you're wrong, realizing that a specific architectural decision failed during a DIRT test has much value.
Negative results are conclusive. They resolve hard design questions. If a web server fails at exactly 800 connections, that's published knowledge. It prevents the next team from wasting time assuming it will handle 1,000.
This proactive acceptance of failure is necessary for the integrity of the whole design.
Right. And the sources argue that we should be skeptical of any document, any design, or any performance review that doesn't detail what didn't work. Rigor demands that institutional knowledge includes the wisdom gained on the quest, the failures, as much as it includes the successes.
So the fidelity is not to the idea of perfection, but fidelity to the system's observable, structured truth, warts and all.
Exactly.
This leads us naturally to the final stage, the path of mastery.
Yeah.
How one becomes proficient and, worthy of the knowledge.
In all three domains, proficiency is achieved not just through learning facts, but through intellectual rigor, continuous discipline, and the strategic control of that knowledge.
Let's go back to the Masonic mysteries. The concept of the secret doctrine is described as the open secret of the world.
It's open, yet it's understood only by those fit to receive it. The core knowledge isn't arbitrarily restricted, but it requires an insight and fineness of mind to appreciate and assimilate it.
This means that the acquisition of knowledge is a moral imperative. It is less a doctrine than a discipline, a method of organized spiritual culture.
Fitness has to be developed. It can't be conferred just by passing along information. You have to prove yourself worthy of the deeper understanding.
And mastery requires adherence to virtues like fortitude.
The steady resolve against threats to reveal secrets or challenges to the established moral geometry, and prudence regulating one's life according to the dictates of reason, ensuring rational control over your actions.
These virtues ensure the practitioner is disciplined enough to guard valuable knowledge and apply rigorous, rational control to their actions.
And SRE has a direct, quantitative analog to this spiritual discipline.
Their radical intolerance for toil.
Yes, toil is defined as manual, repetitive, automatable work that scales linearly as a service grows. It is the antithesis of engineering discipline.
So if an engineer is spending half their day manually restarting servers or performing rote cleanups,
That is toil, and SRE culture deems that fundamentally unacceptable.
and the SRE discipline is enforced by the famous 50% rule,
Right. SREs are capped at spending 50% of their time on operational work, the toil. The other 50% must be spent on engineering project work.
writing code that reduces future toil or adds system features.
This rule is revolutionary because it forces the discipline. It ensures engineers use their specialized coding skills for high-leverage problem solving, rather than getting stuck in an operational rut. The system itself is structured to reward automation.
But who audits that 50%? I mean, doesn't that create a conflict of interest? An engineer could just fudge the numbers to avoid operational work.
That's where the culture of prudence and transparency comes in. The 50% rule is enforced by management, but it's fundamentally a statement of trust. If a team is consistently hitting 70 or 80% toil,
Management knows the system is broken.
or the team is understaffed, they don't typically blame the engineer. They address the structural issue. That high toil percentage acts as a red flag that the system is demanding too much manual heroic effort, which is unsustainable and leads to mistakes.
Automation, then, becomes the path to enlightenment.
The modern spiritual culture.
By automating these rote algorithmic responses, SREs are freed from the constant, highly stressful interrupt state to achieve cognitive flow and focus on high-level engineering.
The goal is to eliminate the need for heroic manual responses. I mean, if a page requires a rote algorithmic response, the team lacks confidence that they can clean up their technical debt. The pursuit of automation is the modern prudence.
Regulating the workflow according to rational reason and eliminating the unnecessary chaos of manual error.
Exactly.
And how is this mastery imparted to the next generation of SREs, the apprentices?
Through a structured process that really mimics an initiation, it's all about developing the necessary fitness required to appreciate the complexity.
So SRE training involves targeted project work that gives trainees a sense of ownership, not just menial tasks.
Right. They engage in purpose-driven exercises, like tracing queries through Google's incredibly complex infrastructure to force a deep system understanding. They are encouraged to become stellar reverse engineers and improvisational thinkers.
Developing the intellectual fortitude required to master the digital system.
And the highest form of mastery involves structured decision-making, ensuring that intellectual rigor, that plumb line of rectitude, governs the direction of the project.
This is maybe the most radical cultural point. SRE focuses on data-driven, rational decisions that win out over decisions based on feelings, hunches, or the dreaded hippio.
Ah, the highest paid person's opinion. In traditional corporate structures, the hippio often dictates architecture or deployment, simply due to seniority. The SRE process is designed explicitly to prevent undue deference to authority when the data suggests otherwise.
So if the hippio insists on a risky deployment because of a financial deadline, but the error budget is already depleted.
The SRE team has the mathematical fortitude to say no.
They do.
They do. Mastery means letting the geometry of the metrics dictate the action, not the paycheck. It requires explicit reasoning, transparency, and a system where the basis for the decision, the SLO, is agreed upon in advance.
It's the ultimate test of fortitude and prudence in the digital age. Having the discipline to ignore the hippio and the courage to break the system via dirty, all while trusting the objective data to make the system stronger.
That's mastery.
So if we step back now, the allegorical continuity between these three vastly separated domains, theology, stonemasonry, and software engineering, is genuinely astonishing.
It really is. We saw the quest for permanence, from Akhenaten's four-square city built to endure forever, all the way to SRE's N+2 redundancy, sacrificing compute power to ensure against the inevitability of decay.
We watched the profound maintenance of textual integrity, from the Masorets meticulously counting every single letter to prevent corruption, to SRE enforcing end-to-end checksums and managing that petabyte-scale recovery of the Google Music data.
And we observed the universal human reliance on abstract geometry for order.
From the Masonic square and plumb line representing moral laws and structural standards,
To the SRE service-level objectives and the mathematically rigorous error budget, which removes fear and politics from deployment decisions and enforces quantitative discipline.
humans, whether they are focused on building a spiritual tradition, constructing a stone temple, or maintaining a global distributed system, employ the exact same fundamental structures.
Demanding profound discipline, rigorously learning from failure through these ritualized quests, and pursuing an enduring form of truth.
Even if they define truth as 99.999% availability. It seems the only real secret of Masonry is the understanding of the symbols, and the only real secret of SRE is the understanding of the system's objective metrics.
In both cases, mastery is achieved by imposing a profound, disciplined structure, be it moral, geometric, or mathematical, on a chaotic reality.
Which leaves us with a final thought for you, the listener. If the greatest success comes from accepting imperfection and imposing objective standards, what system in your own life, personal or professional, needs a clear service-level objective?
And a rigorously enforced error budget. Perhaps if we all treated our goals with the same objective rigor that SRE treats uptime, we might find a little more stability.
Or at least a clearer understanding of when we've exceeded our acceptable risk tolerance and need to pause for some restorative engineering.
Something to ponder as you seek your own personal 5 nines.
Thanks for joining us for this deep dive.